Welcome to everyone. Hi, I am S.A.E.C, Associate Professor, IT Department, and I am from S.A.E. Engineering College. And this is a good infrastructure institute with a space of nearly square feet of large areas. And we have UG programs with BE, EC, EEE, Mechanical, Civil, and then BTech with IT and BTech AIDS and BTech CSBS. And BE we have a Mechanical, Civil, and EC, EEE, CSE. And we have a BE CSE with the A and ML, and we have a good infrastructure and with a capacity of large infrastructure with the laboratory equipments. And here I am just continuing with a session of operating system that was enclosed with the GATE coaching for the benefit of students, those who are undergoing the GATE questionnaires. And here I am just specifically going for the memory management, which was the very important topic in GATE. And here this is the syllabus that covered in the operating system. And first we go for the system calls, process, threads, and the communication process, synchronization that deal with the deadlock, and then CPU and IO scheduling. And memory management, we have a virtual memory and file systems. So these are the syllabus that covered in the GATE that particularly have a percentage of 10 with the scoring of at least 2 to 4 questions from the operating system. And here today I am just going to concentrate on memory management, and this is the content that I am going to explain you. First of all, we need to understand what is exactly the memory management and what is the role of memory management, then the techniques involved in this, and the two process, that is a contiguous and non-contiguous memory allocation, and finally about the conclusion part with similar patterns of questions that expected in the GATE. And now starting with the memory management, as you all know that the data are spread wide over the world, and today's world is expected more number of memory to enclose or encompass all their data. So even though many technologies have emerged, still the operating system in the questionnaire view, and that challenge will be faced by many softwares. And today I am just going to tell you what is exactly the memory management, how it can be solved through the management techniques. First, the memory is just a way how you are keeping track of your data. So if I am handling the data and we have a PDF file, we have a PPT, we have a document, or we have an image file that are all compressed and stored in our memory, and that system will encompass all the data. So the computer system has to be in the position to encompass everything. So this is the amount of main memory that accommodates. So this is a picture that depicts how the memory management is skilled over that. So for example, here we have so many files that will be closed with this rack. So the memory management should efficiently handle the memory management techniques to have the file racking. So here the successful partition is to be make the allocation in the proper scheduling, and this is the world today that covering the entire management. When talk about the memory management, this is the entire architecture, and here we deal with each and every several unit of operating system that cover with these technology. Here the first is a memory management, that is a user program. This is the client interaction user enability. So when I am dealing with the user programs, it automatically encompasses with the client, and that includes the user enability to the interface. So when through the program the client is contacting with the interface, and those interface will call through the system calls. So when we have the system calls, these number of management techniques should be there to accommodate our entire OS. Say for example, the first one is the file management, where you should keep the track of files which is stored in the spaces where the entire OS to be covered. And the file racking is a different area where operating system is a successor to have all these file management. And second is the memory management, where the entire storage and memory capacity should be controlled over through the OS. So this is a very major task. And the technique that followed next is the process management, and the next one is the network management, and final is the power management. So these are all the techniques that covered through the operating system, where the entire hardware getting supported and the OS is enabling the entire files and other data to be enrolled with our own system. This is what the entire memory management techniques. So with this introduction part, I just move on to to the memory. Why we need the memory first? So first of all, when we have the capacity of controlling or storing our data, the entire scenario will be like this. Say for example, previously it was registered like a registers. So first it was a register, then it has the controlling over the storage of magnetic tapes, and in the second level it was an optical disc, third it is a magnetic disc, fourth is the electronic disc, and the main memory. Then we go for the cache and then registers. So when we have this cache memory, we almost cover all the spaces, and that imposes the operating system functionality. Next, when deal with these cache memory and main memory, this is not sufficient for holding all our data as a storage. So in that cases, we need to go for the memory management role. This is a very important one, because when we have the storage allocation, it's not only the job of accommodating that storage with a proper scheduling, but also we need to have a control over that memory, and whenever it was required for the retrieval, it should be processed completely. So the memory management takes a responsibility of handling the data with those memory management retrieval also. So that's why we go for the role of memory management. So it just to keep track of the status of the memory locations, and then immediately the memory manager permits the files to have the updations on it. Say for example, if I am saving the data and it was saved in some other memory, but if whenever I want a retrieval, it automatically retrieves from the memory management. But there is a role of memory manager who always permits our memory allocation to execute the programs and keeps on track on it. So whenever the keeping track of that, the every amount of available memory should be accommodated with a proper utilization. So once the utilization is not completed, then automatically the memory management gets failure case. So this is controlled by the memory manager. So whenever required, the memory manager takes the charge of keeping on track the entire memory unit, and they will find out which is the most least utilized memory, and then they will give you the allocation of those memory whenever we required. And there is a two process. The memory management techniques involved contiguous and non-contiguous. So when we tracking the information stored upon the memory management, there is a two implementation. One is through the contiguous and another is with the non-contiguous. So as you know that the storage level is of entire utilization of the operating system. So when the operating system is getting filled with the memory unit, obviously we need to make a fetch of other data also. So in that position, we need to we need to find out which is the major main. So the non-contiguous is a vital role that played by the operating system to make a successful memory management. So first of all, I just tell you through the flow diagram how the entire allocation is partitioned. So first, this is a first scheme, that is a memory management scheme, and it is controlled with a contiguous memory allocation, and second is the non-contiguous memory allocation. So while coming to the contiguous, we have a single file system, single management system, and secondly we have the multiple partitioning. So in multiple partitioning, there are two systems. One thing is fixed and another is the dynamic partitioning. So when dealing with these classification, the entire multiple partitioning techniques take a charge of making this fixed and dynamic partitioning, and the second category is about non-contiguous, where the whole concept of paging and segmentation getting involved. So when you take a concept of contiguous and non-contiguous, the entire scenario will be again partitioned, and those classifications are controlled over it. When comes to the point of contiguous allocation, just here I am just giving you the example where in contiguous allocation, this is what the entire memory management is getting splitted. So here inside the memory unit, there will be the partition of blocks where each individual single blocks are getting engaged with the data what we are fetching there. So as I mentioned earlier, user interfaces or through the client program, we are just going to update the data, and those data are in the format of image or picture or a document. They are all getting into the blocks. So as a invisible learner, we couldn't identify in which block it was going to save, but in the memory unit it was like a block, and each and every block is now getting engaged with the following data. Here I am just giving you the three examples. One thing about document, memory unit and video, and then one is a document, and here they take a continuous allocation of a blocks from 0, 1, 2. So this in this this picture, 0, 1, 2 is getting engaged with the first file, and second 4, 5 is getting engaged with the video, and 9, 10, 11 is getting engaged with the document file. So 3 different formats in the same memory unit, but in the different blocks. This is the contiguous memory allocation. So here a set of memory locations with the consecutive addresses. So while expecting gate questionnaires, you can have a question like a allocation of blocks or allocation of the memory unit. So as a learner for the gate coaching, you have to understand what is logically addressed here. So when a thorough knowledge of logical addressing and IP addressing in the networks, that helps you to identify where the important memory management is handled in the operating system. Then the entire contiguous allocation focused on the category of each and every generations of computer. So when the single contiguous memory unit is the simplest way of achieving the target of operating memory unit, this is the way how they are utilizing the scheme. It's like a previous generation of computers. Say for example, we have a large hard disk with a memory of main memory, cache and registers. All these things will be entirely handled by a single unit. And in the second category, we have a multiple partitioning where the entire unit of this processor is allocated with a separate unit. Say for example, here I mentioned about process P1, which handles with a 10 KB of size. So this 10 KB of size will be segregated inside the memory unit. Say for example, first space is about 4 KB, second is about 21 KB and 10 KB. So as a first input, the 10 KB entire file will be handled in the 10 KB. But in the contiguous memory allocation, we cannot move up the memory, but just we can handle the data to the operating system. The operating system itself make a contiguous allocation and it always fetches to the larger memory space. So if I am having the 10 KB, but the actual accommodation is about 20 KB. So when it is coming into the 20 KB, the remaining 10 KB will be in the free space. This is not properly managed in the contiguous memory allocation. That's why even though it was a multiple partitioning, it handles with a single fixed partitioning, and talks about a multiple partitioning with a dynamic environment. We can handle those things. So this is about fixed partition. Say for example, here the process P1 has a limitations of 3 MB. So the storage of 3 MB is handled with the process P1, and the entire memory is unit of a whole MB is accommodated with 3 MBs. So if I am having the extra memory space, that will also be controlled like a partitions 1, 2, 3, 4. Each partitions with a minimum of 3 MB can be have access of this process P1. So I hope you clearly understand. Process P1 can have a 3 MB file storage, and that will be given as a partition from partition 1 to 4. And wherever we have a 3 MB, it automatically gets fetched, and this will be handled by the remaining unused space. So here as a consolidation, we have a 1 MB from the each partition. Say for example 1, 2, 3, 4, we have a 1 single MB from each partition. So totally we have a 4 MB as our partition as a free space. So this free space is now calculated while using the multiple partitioning, where it is not available in the single partitioning. Fixed, this is about the fixed, and this is about the dynamic. So in the multiple partitioning, there is a two different concept. One is fixed and another is a dynamic. And in the dynamic, we have a process P1 to P4, and again they have a different memory storage. Say we have a 5 MB, 2 MB, 3 and 4. And again when it comes to the process, we have the partitioning, and each is having their own storage. And now the contiguous allocation in the dynamic way capture all these things through the partition. So partition 1 to 4 now can able to have each and every MBs, and these free spaces will be freezed with a proper partitioning. In previous things, we cannot have a free space with the unused concept, but in the dynamic partitioning we have a good spaces that allocated with the exact location. This is a major difference in fixed and dynamic partitioning. So as a clear view, you can understand that from the fixed partitioning, you can have a gathering of a unused space. But in the dynamic partitioning, it actually allocates the memory where we required. For example, 5 MB means 5 MB it will allocate. So there is no gathering of unused space. So this is the two main difference in the fixed and dynamic partitioning. And we comes to the non-contiguous memory allocation. This is what the entire scenario. Say we have a main memory, and in that main memory, if I am having the storage of a KB level, then again these unused space is now collected. So instead of looking over to the file system, here clearly they will control the processes with the memory unit. And again in the operating system we have a partition, and how many partitions we have, how many processes we have, all these will be gathered, and those processes will be controlled with the additional of all those spaces. So this is what non-contiguous will do. So when it comes to the non-contiguous, they are not necessarily to be the adjacent one. In contiguous it should be adjacent, that is sequentially it was allotted and each memory space will not constrain about the other thing. But here it was not in the thing that it should be adjacent or synchronized. It should be, can be a non-adjacent. When comes to the point of the next one, the non-contiguous has the concept of paging. So as you know that paging represents the way how data is getting organized. So here I am having the index reference, and each reference is accommodated with a logical address, and they are separated with the page number and the offset. So when we have these allotment, the frames are easily dependent on each other, and they can be organized accordingly. So here the main concept of paging is controlled under the non-contiguous allocation, and we can expect the questions for the gate from the paging also. And this is the second category, which is called the segmentation. So apart from paging, why we need the segmentation is, here we have the logical addresses and they are segregated and we are gathered with the frames and offsets. All these things will be controlled, and we have a good knowledge of paging. So after paging, if I am replacing with that algorithm, say for example there are so many page replacement algorithm, the least used allocation and most used allocation, all these things will be analyzed through the paging. But when it comes to the paging, after that result, what we need is a segmentation. Segmentation creates the offset, it adjusts the offset, and it always allocate the memory with a proper non-contiguous allocation. So when it comes after the resultant of the paging, we have the memory storage in this, and after that we have the logical view of segmentation that has the paging concept. Say for example, if I am having the user space of 1, 2, 3, 4, and again apart from that I am having the free space, then it goes to the physical memory unit, and now it was automatically generated with the segmentation. So this is the way how the memory management techniques are utilized through the paging and the segmentation. And we can, from this learning process, I am just going to give you the view how we can expect the gate questions and how they are related with the previous analysis. So here from the paging or segmentation you can expect at least one question, and from the memory management techniques you can expect 2 questions. So totally we can expect 4 questions from the memory management, and memory management alone has the 10% role of giving a virtual memory and then physical memory. All this thing will be have a conclusion of at least 2 to 3 questions in the GATE class coaching center. Then we have the examples of questionnaires. First one, I just giving the tables and the order of the way how the each page reference is getting enrolled. So here they given the demand paging system with the 3 frames. As I mentioned that these are the 3 page frames, and each frame set is allotted with the numbers. So once initially it was null, and after that, after the allotment, it was getting engaged like this. So the star represents that they are really offset, and during each revolution it will be placed. So here we need to find out the which part of the thing is applied in the paging system. So they have given 4 options: least recently used, least frequently used, most frequently used, and optimal page replacement policy. As you know that the given number of offset is controlled over it, and after that each and every page will be replaced with a 1, that is a most frequent used, and again 6. So once it counters 1, again it starts with the 6. Again it comes to the 1, again it starts with the 2. So similarly, they have the page replacement, and it was done with the least frequently used page replacement policy. So when you talk about this 4 is not utilized properly, 1 again 5. So all these things will be again to be utilized. So it always uses algorithm, least frequently used algorithm. Second question, it's about the page replacement. So first, I will just tell you which of the following page replacement algorithm suffers from Bilardi's anomaly. So Bilardi's anomaly always focus on the first in, first out. So when we have the page replacement, the first in, whenever the memory takes over the charge of the space, then it automatically takes the scheduling of FIFO order. So the answer for this question is FIFO. Then the third question we can expect with the normal integer calculation, that is, here they given the level of hierarchical partition. So here they use 2 level hierarchical paging, and with that hierarchical paging 2 to the power 32 bits are utilized, and those each entry will be inner partition, and they try to understand the B. They want to have the B level of counting. So here they are asking for the calculation of n number of bytes, that is B. So here the value of B can be the integer. They given the hint, and now the answer will be the first B bit of index to be calculated from the 2 to the power 32 out of 4096 bytes. So this will be enrolled that after calculation the answer will be 11. So here we are just having the same size of set of paging. So if I implied that with the entire scenario, then we will get the answer is 11. And then the fourth question we can expect from the page replacement algorithm. So they are given a set of count, that is a paging, and in each system they mention that 3 memory frames that are initially allotted and empty, that they are empty, and after that the number of page faults will be occur. So during that, how many page faults you can expect? So this is the real question. So when you encounter these things, the number of list happens, and each time when we are applying the page replacement policy, then the answer will be 6. So these are the similar patterns that we can expect from the gate coaching, and when you are having the memory management, definitely you can expect questions like this, and majorly from the part of paging. So this is about the gate scenarios that happened every year in the operating system subject. So with that conclusion, I just mentioned you what exactly the memory management. So it is a vital aspect that helps to ensure the process that run in the virtual memory and memory unit, and this is a technique that manages the functionality of primary memory to achieve the better concurrency and utilizing the memory with the proper page replacement algorithms. So this is the way you have to learn for the gate, and you have to prepare for the gate coaching. Okay, as of now we just end up the memory management, and I will just explain you through the next session. Thank you all. We will meet you on the next slide. Thank you.